I welcome all of you who are interested in understanding this particular concept in maths. Let's look at the question. A sequence is given as log 3, log 9, log 27, and it continues. That's the meaning of those dots. Okay. Determine whether the sequence is arithmetic or geometric. Give a reason. Okay. So the question is asking us to determine whether the sequence given is arithmetic or geometric. For that, we need to understand what do we have to find to tell us that it is arithmetic, and what do we have to find to tell us that it is geometric. So for arithmetic, we will have to look for a common difference. If there is a common difference between two consecutive terms, that means it is an arithmetic sequence. But if there is a common ratio between two consecutive terms, then it will be a geometric sequence, and that will be our reason. Okay, so that means we will have to try that. Okay, let's try geometric first. Geometric, that means there should be a common ratio. That means when we divide T2 and T1 and T3 divided by T2, it should have the same answer. I will just label this so that it's easy for us. T1, T2, T3. But remember, this T1 is also our A, because in the formula A is there and A is nothing else but T1. Okay. So we have to try for geometric first. That means we have to divide T2 divided by T1. That means log 9 divided by log 3. So the answer is 2. T3 divided by T2. If it is also 2, then the sequence is geometric. If it is something else, then that means this sequence is not geometric. Then we will try for common difference. Okay, so log 27 divided by log 9. Log 27 divided by log 9. So the answer is 1.5. It's not 2 because log 9 divided by log 3 was 2. But now when we divide log 27 divided by log 9, it is 1.5. So that means this sequence is not a geometric. So that means it should be arithmetic. So for arithmetic, it should have a common difference. But there is one application here because log is involved. That means we will have to use the log properties of log. Okay, so the properties of log says when we subtract, so it will be common difference equals T2 minus T1. So that means it will be log 9 minus log 3. So what will be the answer? From here, when we subtract, this property is from your textbook on page 27. Okay, there are other properties there, but I just wrote these two because one of them we will use here. We'll be using this one. Log of same base. When the base is same, whatever comes after log, we will have to divide that. Base is same. Okay, but something you need to note here, if the base is not given, then we assume the base is 10, and that means we can also just write log. For example, log 10. Log 10, we can just write log instead of log 10. So in our question, you can see only log is there. The base, this part is not given. But that part is 10, and we can just ignore that and just write a log. Okay, so that means if we compare this property here with what we have there in our common difference, then it will be just 1 log. We have to divide the whatever comes after log. It's 9 and 3, so that means 9 divided by 3. So that means our common difference is log 3. We have to give a reason, so your reason will be because it has a common difference. So this means that this sequence is an arithmetic sequence, and the reason because it has a common difference. Okay, just to be sure, if you want to check the other two consecutive terms, if the answer is also log 3, so that means following this formula here and the working, it will be just 1 log. I will just do the working here because there's no space there. Okay, for these two, So common difference, now t3 minus t2, the answer should also be log 3. That means log 27 minus log 9. Following this property of log, we will have to divide the two numbers. So just one log, 27 divided by 9, and 27 divided by 9 will give us 3. So also log 3. So that means the difference between two consecutive terms in this sequence are common. The difference between these two is log 3. Difference between the other two is also log 3. So that means our common difference is log 3. And give a reason for your answer. So that means this is an arithmetic sequence. Arithmetic sequence. And the reason will be because the sequence has a common difference. Okay, so that will be our answer for part A. For part B, okay, so that means this is an arithmetic sequence. That means we'll be using the arithmetic sequence formulas to calculate whatever comes after that, whatever that question is asking. Show that the 10th term of sequence is 10 log 3. 10th term. Okay, so what is the meaning of 10th term? 10th term simply means our T10. Okay, so from question part B, we can see that T10 is equal to 10 log 3, but we have to prove this. We have to prove that T10 is equal to 10 log 3. So that means we will use the nth term formula here for arithmetic sequence, since this is an arithmetic sequence. So what is the nth term formula for arithmetic sequence? The nth term formula is Tn equals a plus n minus 1 d. Okay, we are looking for T10, so that means our n will be 10. In place of n, 10 is there. So that means in place of n on the right hand side, 10 will also go there. A, our first term is log 3, okay, plus our n is 10 minus 1, and our common difference we have already calculated is also log 3. Okay, I will just list the information this side so that it's easy for you. Okay, A is log 3, the first term. Okay, n is 10, and our common difference is also log 3. Note our A and D is both log 3. Okay, now solving further, it will be log 3 plus 10 minus 1, bracket first, Bedmar's rule will give us 9, and 9 times log 3 is log 3. Okay, so at this step here, you can see the like terms are there. Remember, like terms in log, whatever comes after log is same. So after log is 3, after log is also 3, then we consider that to be like terms in log. But remember, there's no number here, so that means this is 1. 1 log 3 plus 9 log 3 like terms, that will be 10 log 3. And we have proved that T10 is equal to 10 log 3. So that means we have proved that answer, and that is correct. Okay, the last part of the question. The last part of the question is asking us to show that the sum of first 10 terms of the sequence is 55 log 3. Okay, so now it is asking about the sum. So that means we will use the sum formula for arithmetic sequence. So what does our sum formula looks like? It says Sn equals n over 2. Okay, then 2a plus n minus 1 into d. Okay, show that the sum of first 10 terms, sum, so that means as 10, and the answer should be equal to 55 log 3. So that means 10 will be our n. In place of n, 10 will go there. So that means in place of n on the right hand side, 10 will also go there. In place of n, 10 is there, divided by 2. 2, our first term was log 3. So 2 into log 3 plus our n is 10 minus 1, and our common difference is also log 3 close bracket. Okay, 10 divided by 2 will give us a 5, and inside the bracket 2 times log 3 will be 2 log 3 plus 10 minus 1 will be 9 and the log 3. Okay, note this log 3 here is just a number. It's a small number. You will not do this. You will not multiply 2 to log then 2 to 3. That will be totally wrong. Okay, I'll just solve further, then I'll show you that step. Okay, because I know some of you will make that mistakes. So continuing that step, 5 will come down. 2 log 3 plus 9 log 3. Note they are like terms, because whatever comes after log is same, so we just add the numbers in front. 2 plus 9 will be 11. 11 log 3. So 5 multiplied by 11 log 3. So this is what I was talking about. You will not do this. You will not multiply 5 to 11, then after that multiply again to 3. Note that this log 3 is just a number. It's a number, but it's in decimal. It's very small. If you press in the calculator, just see there, it's 0.47. So let's just say this number multiplied by 11. So it's 5 point something. So it's same as you just multiply this number with whatever is outside. So that means we just multiply 5 to 11. 5 multiplied by 11 will give us 55, and the log 3. Note the log 3 is just a number. It's the decimal point of that number. So this is 11 point something multiplied by 5 will give us 55 point something, and that point something is that log 3 there. So we have proved that S10 is 55 log 3. So that means that is correct.